This is Rahul Shaw, and in this tutorial, we are going to learn about closure in JavaScript. So, closure is a combination of function bundled together with reference to its surrounding state, the lexical environment. Okay. In other words, closure gives you the access to an outer function scope from an inner function. Okay. So, lexical scoping basically they are giving this example. Okay, so here what they are telling, like this inner function will have the access to the outer function scope. So that's why this name is printed, because this name is not present inside the display name. So it is going out and checking the outer scope. Okay, so here like this name is present. That's why this is printing this. Okay, so this is lexical scoping. So lexical scoping is also called as closure, right? But what is this lexical environment? Is it like surrounding states? Okay, let's check this lexical environment in JavaScript. So lexical environment is a data structure that holds an identifier variable mapping. Here identifier refers to the name of the variable function and the variable is the reference to the actual object. Okay, let's go inside this. Okay, so now we have here oh, a lot of things are there. So basically here if you see this, when executing a function or a script, the JavaScript interpreter creates a new context. Okay, that is fine. Every script function has a base context called global execution context. Okay, so this is like a global where everything will be created. And every time we call a function, a new execution context is created and is put on the top of execution stack. This still here it's clear. Okay, basically they will create a like call stack that they are calling like execution stack. So whenever like Java will create a new function, so that time like it will just put that function in the call stack. Okay, on the top of the call stack. The same pattern follows when you reach the nested function, which calls another nested function. So suppose like we have this function, right? So first this will be created in the global scope, okay, global execution context. Then again we are calling this, right? So again like if there will be a call stack, right? So first this function will be present in the call stack global execution context. Okay, so on the top of that, like this function will be created. Okay, so the next whatever the execution context is there, that will be present on the top of the global execution context. Okay, so once this function will be resolved, that time this will be popped out from the stack, and again control will comes to the global execution context. Okay, till here it's clear. Okay, so whatever number of nested function it will execute, it will just create a new execution context, and it will put on the top of the call stack. Okay, so now they are telling like there are two scopes in JavaScript. One is a global scope and another one is the local scope. Okay, so global scope, there is only one global scope throughout a JavaScript document. Okay, we can access and change variable in global scope. Okay, so if we change anything in the global scope, so it will be available like everywhere, right? As per this meaning. Okay, so let's see this example also. Okay, let me just uh, comment this and we can create one variable name here. Okay, let's define this as let name is equal to some xyz. Okay, let's create one function here. Function set new name. Now again if we define name is equal to abc. Okay, so what will happen now if we call this set new name function? Before that, this let's call console.log name. Okay, and like basically call this function, and again let's call the same thing. So as per this global scope, it should change this name variable, right? First it will print xyz, then it should print abc. Let's see this. Yeah, correct. Okay, so till here we are clear, right? Now let's come to the local scope. Variable defined inside a function are in the local scope, okay, and they have a different scope for every call of that function. Okay, this means the same variable name can exist in other function as well. This is because those variable are bound to that scope. So now if we see here, they are telling, uh, if you see this example, what they are telling, here they are calling my name function, and my name function is calling the find name. Okay, and find name is calling the print name. So like that, it will create a execution context. Let's see what first my name variable will be created in the global execution context, and the function will be attached to it as a value. Okay. So in the call stack, it will create this function. Okay. Then when we go inside this function, that time it will call find value. So again, a new execution context will be created, and it will pushed on the top of like call stack. So like that, if you see here, find name execution context. Okay, so again, like this will call the find name, and this find name basically execution context will be created, and again it will just go inside this print name, and it will create a new like execution context. So that will be in the top of the call stack. So once this will print the console.log max steel, so it will be popped out from the call stack. So it will be gone. Now the control will come here, find name execution context. Okay, so once this function will be resolved, again it will come to this function. Okay, again this function will be popped out, so it will come to again global execution context. Like that it will work. Okay, so now if you see here, this is like a code function global. This is fine. Now we are coming to this lexical scope. Okay, the scope chain helps to resolve variable. When a variable need to resolve, JavaScript start from the innermost level of the code and keeps jumping back to the parent scope until it finds the variable it's looking for. Okay, so it's telling like whatever we defined like in the inside of the function, if it will not be able to find out, so it will go in the top like outer scope. Again, it will search here. If it is not there, it will go on the global scope and it will search. So like that, wherever it will find, it will just print the value. Correct, right? So now let's come to this lexical scope. So when we have a nested group of function, okay, like function inside the function, the inner function has access to variable and the other resources of the parent function. Till here, like as this is the definition of closure, right? This means child function are lexically bound to the execution context of their parent. Okay. Ha, child function also will have that access, right? Okay, okay. There will be a lexical scope. Hmm. Okay. Okay. So if you see Anna, how they are calling this, like find my name. Okay. So like if you see find my name bracket start close and then bracket start close. So it means what? It's executing the inner function also. So if we can create something like this, okay, the same like code I am enabling here. Okay. So here we have a name, right? Name, we have the value, then again function. So we will not call this function like this. Okay. Let's return this function. Okay, and let's not define everything here. Okay, let's call one more function. Let's return one more function. Return function uh, inner display name. Okay, and now here we are going to define this console logs. Okay, so now if we call this init, what will happen? So this, if we call this init, so it will print some function, right? Okay, we have not printed anything. If we call here console log, so it will print some function. Yeah, it is printing like we have this is returning some function display name. So now let's call this like this. So what it will call, it will print, it should print inner display name. So now if we call like this, now it will print something like whatever name is there. So it's printed Mozilla and then undefined. Why undefined? Why undefined? Okay. Undefined is basically first it printed this console log, okay? And then, yeah, we are not returning anything. So that's why this is undefined. Correct. So, oh, here. Okay. Yeah, let's return the name here. Okay. Now it should print Mozilla. Maybe this is some deprecated reserve word, right? Let's call this as a n name. Now this will show. Okay, now what I wanted to do is basically suppose we are passing here 1. Okay, we are passing here 2 and let's pass here 3. Okay, ha, I, J, ha, correct, correct, correct. Yeah. So basically, now what it will print? Now if we print I into I plus J plus K. So first, this will start searching for this. So like it will get the value K from here only. Then it will start go in the outer function. It will search for J. It will get it. And then again, it will go for the outer function. It will get from here. Okay. So let's see this. It should print like, yeah, this is correct, right? This is the example of like closer. So we can use something like that. Let's come again to this topic. Now let's come to this lexical environment. Okay, what is this lexical environment? When the JavaScript engine create a new execution context for a function, it create a new lexical environment to store variable defined in the function during the execution phase. So till here I'm okay. Like when JavaScript engine creates a new execution context for a function, okay, it creates a new lexical environment. So maybe like some environment parallelly it is creating where it will store all the variables defined in that function. Okay, for what like whatever lexical scoping is for what like this execution context is created. Okay, so suppose this is whenever the JavaScript will create the execution context for this. So whatever variable inside this, okay, function, so that it will create a it will store that variable in the where in the lexical environment. Okay, so same for this, it will create a like execution context, and it will create a like in lexical environment where it will store the variable I. When it will come here, so again it will create a new execution context, and it will create a environment lexical environment where it will store this variable, right? Again it will create a new environment context, and it will store this variable k. So when it will just return ijk, so I think it will search this I first in the inner whatever the execution context is created. For that I think some lexical environment is created, so there it will start searching for I. If it will not be able to get that I in the local lexical environments, then it will go on the parent lexical environment. So again, if it will not be able to find there, it will go on the parent. Like that, I think it will work. So it is telling that a lexical environment is a data structure that holds an identifier variable mapping. Okay. Here identifier refers to the name of the variable and function. Like that, what we discussed now. Like for every variable, it will create a key and value, right? For every function, it will create a key like as a function name, and then value as a whatever the function scope. So that will stored. And the variable is the reference to the actual object, including function type, object, or primitive value. Okay. So lexical environment contains two components. Environment record. Okay, it is the actual place where the variable and function declaration are stored. Okay, declaration are stored and variables are stored. Okay, reference to the outer environment. Second thing is a reference to the outer environment. It means it has access to its outer lexical environment. Okay. So if you see this program, here is a variable language JavaScript. And then we have a function, okay, A, constant B is equal to dot console log. We are printing that console log, we are printing something inside function A. And then we are calling A and then we are calling this one. So what will happen? So first, in the global execution context, it will create a first it will create a language, okay, and it will create a variable, okay. So in the A, if it will see like language is a variable, so it will create in the creation phase, it will store the undefined in this, okay, and it will store for A, it will store the function, okay. So when we are calling that function, so what will happen? A new execution context will be created, and in that a new lexical environment will be created where it will store this variable b, okay. And then once the in the inside the execution context, once it will start print this, okay, so then it will this will remove from the call stack, and then it will come, control will come here, and it will print like global execution context. Let's see what is happening here. When the JavaScript engine create a new execution context for global, it create a new lexical environment to store variable and function defined in the scope. It looks like this. See, global execution context is there. It's like an object, okay, where we have a outer and a environment record. And environment record, we have a variable language which stores the value JavaScript, and a function name, okay, function name, right? Yes, which is a reference to the function object. And in the outer, there is none. Why there is none in the outer? Null in the outer. What it is telling, reference to the outer environment. Okay. So in the global only it's created, so outer is null. Okay. So when the JavaScript engine creates a new execution context for function A, okay, it create a new lexical environment. Again, see here how they are creating this. Okay, when the control will go to this, when the JavaScript will create a new execution context for this A variable, so it looks like this function lexical environment record. They are creating this B. Okay, like how this B is there now B. Okay, and in the outer it will just add the global lexical environment. Okay, like that. Now see, I got the understanding like how it is working. So for when we are in the global execution context, that time the outer will be null because there is no outer reference. And in the environment variable, we will create all the variables and web functions. Okay, but when it will come to the local uh, execution context, okay, that time what it will do in the environment record, it will create all the variables and functions, and in the outer it will have the global lexical environment. Okay. Yes, yeah, correct, correct. See, this outer will have this complete thing. Okay. So when the function complete the execution, it may or may not be removed from the stack depending on if that lexical environment is referred to by any other lexical environment in their outer lexical environment property. So that's it for this article. I know this is a lot to consume in the single article. I hope it was helpful. Yes. So I think this is fine, right? We can take this as a reference. Yeah, I've shared this link in the group. Okay. Now let's come to this topic again. I think now we are clear with the global execution context also and execution context also. Now we are clear with the yeah lexical scoping also, lexical environment also, and what about next? Global scope, local scope. I think these all topics are clear now, right? Now, now see they are telling something more here. Closer. Now we have this function. So what will happen? How in the global execution context this will be executed? Now can you explain? Now like if you see here, my function is there, which is a variable. Okay. And when like in the global execution context, it will have this, it will create a new local execution context for this function, which will have this all things. So it will create a new local environment, lexical environment, where it will have a name and a display name which will hold the reference to this function. Okay, like that it will work, right? Now we are clear on this function. So I think this all topics are clear, right? The reason is that the function in JavaScript form closure. A closure is the combination of function and the lexical environment within which that function was declared. This environment consists of any local variable that were in scope at that time the closure was created. In this case, my function is a reference to an instance of the function display name that is created when make function is run. Okay, this is all fine. We have defined a okay, and I think practical closure something they are telling. Let's see what they are telling in practical closure. Closure are useful because they let you associate data with a function that operates on the data. This has obvious parallel to object-oriented programming where objects allow you to associate data with one or more records. You can use a closure anywhere that you might normally use an object with only a single method. Situations where you might want to do this particularly common on web. Much of the code written in front-end JavaScript is event-based. You define some behavior and then attach it to an event that is triggered by the user, such as a click or key press. The code is attached as a callback, a single function that is executed in the response to the event. Suppose we want to add a button to a page to adjust the text size. One way of doing that this is to specify the font size of the body element in pixels and then set the size of the other element on the page, such as headers using the relative EM unit. Okay. Such interactive text size button can change the font size property of the body element and the adjustment are picked up by other elements on the page thanks to the relative unit. Okay. Now we are telling like size 12 make sizer and we are passing 12 here. Okay. So this is returning a function with document.body.style.font size. This one. Okay. So see like how we are just changing dynamically the size of this font size in the body level, right? Mhm. Now are now function that resize the body text to 14, 12, 14, 16 pixel respectively. You can attach them to a button. Okay, so when we click on size 12 button, so we can attach this. We can attach this to 14. We can attach. So what is the need of this like doing this way? We cannot do directly, like we cannot return directly like what if we will not use this return? We can directly like cannot write like document.body.style.font size this pixel. So what will happen? Okay, okay. Hemant, are you there? Yeah. So you got it. Like why we are using the another function here? We can write like this also, right? But still, like we are returning some function. See, basically what we are doing here is here we are calling one make sizer 12. Okay. So this is returning a new function which will be stored in the inside this size 12, and this size 12 we are attaching to the button on click event. Okay. So this is the way like we can use this. Yeah. So now if you see the another example, okay, this one, the following code illustrate how to use closure to define a public function that can access private function and variable. Define public function that can access private function and variable. Note that this closure follow the module design pattern. Okay, so we can create a module design pattern also. Okay, we can wrap more number of functions inside of single function. Okay, like this, whatever we have tried it for the stack operation. See here there is the counter, right? In the counter function, okay, what we are doing, okay, here we are forming the IIFE also. If you see here, the first bracket and the last bracket, we are like following the IIFE also, like we are attaching some function to this counter variable. And here, if you see, it has the inner function also. Okay, so it's an example of closure also, and we are returning that whatever, if you see that increment change by, okay, okay, then value return private counter, okay. Yeah. So I think this is also clear, man. Do you have any doubt in this? So now here there every closure has three scope: local scope, own scope. Enclosing scope can be block function or on module scope, global scope. Okay, the common mistake is not realizing that in the case where outer function is itself a nested function, access to the outer function scope include the enclosing scope of the outer function. Okay, so if this is the global scope, function sum A, return function B, return C, outer function scope, return function D, local scope. Okay, now A, B, C, D, E, like that we have tried, right? You can also write without anonymous function. Anonymous function we can write like this: return function sum2. Okay, sum2. Okay, okay. There are a lot of examples, and we can explore this more if you want. Okay, see how we can create a module.js file, and then we can attach it here, and then we can use it. Closure in loops. Yeah, creating closure in loops, a common mistake. Okay, like show help. Okay, man, I think this is enough for closure, right? Yeah, yeah. Gana is there or not? Gana, hi Gana. Are you there? I think Gana is not in the call, or he's in mute. Okay, let me just close this session for just this closure. Okay.